Hello guys, how are we doing today? Perfect. Thank you all for joining, for those that attend in the office and for those that have joined us online. So a little bit about us, if you haven't heard of us or what we do, this is the DevOps Playground. So this is run by ECS, and today we have Ondat with us. Thank you very much for coming, Nick. So without further ado, I'll get straight to it. Right. So today we're doing hands-on with stateful apps on Kubernetes with Ondat, and it'll be Nick who's going to be presenting for us. For those that don't know ECS and what we're about, ECS is a digital transformation consultancy, and typically what we do is we'll get a partner once a month, or a consultant of ours. They'll pick a tool, get hands-on, and get you guys to come in now. Or online, and to go through the application or tool, to have fun, eat some pizza. This is the first event we've done in the office for 2 years, which is really great. Thank you again for those that have come in. Really appreciate it. But I'll pass it straight on to Nick to start. Perfect. Yeah. Great. I'm not sure you connected the mic. Perfect. Yeah. I'll take this one with me. There you go. Thank you.
Good evening now, everyone. So today we're going to be focusing on taking a look at Stateful Set. But before that, just want to introduce the team for today. So there is myself, Nick, Yasmin, who is there, who made also, this nice banner happen. And we have Angelos for technical, issues if you have anything. So I'm not sure how it works if people online want to ask questions, maybe via the chat, I guess. So via the chat, Angelos can answer. But before going to the lab, so maybe the format for today will be, I'm going to talk a little bit to set the level in terms of Kubernetes object notion, what we're going to be working on. So hopefully, the expectation is that you guys are at least familiar a little bit with Kubernetes, meaning that you can do a little bit more than just spell it, right? But first, let's set the stage. We're going to talk about stateful set deployment, some of the basic application primitives, and then we'll go into the lab. For the link, we'll post it on the chat as well. It will be on GitHub on my personal repo. Okay. So why stateful sets? Why now? So the first thing, if you look at what is on the screen right now, it's a report by Datadog, which has been updated in October. So that's 2, 4, 6, 8, 10, 12, 14. So that's the top 14 container images used in the industry. So if you look at that, we have Redis, Elasticsearch, probably RabbitMQ is one, MySQL, Mongo, Kafka, etcd. We have almost like 1/3 which are stateful application, right? So it's not like a myth, although Kubernetes was not necessarily the first platform you can think of in terms of running stateful application. It started to become the norm, right? But there are kind of challenges with this. We're going to see them later when we go through the lab and when I will highlight the difference with deployments. But first, a little word on that, just 2 minutes to tell you guys what we are doing in this space. So effectively, you can think of Ondat as a hyper-converged vSAN type of environment for Kubernetes. So especially, we provide this layer where you can provide extra features for your persistent volumes. So typically, when you use a stateful set, it needs to write data to disk, and this data needs to be persistent, right? So, but Kubernetes doesn't provide any sort of primitive to do things like replication or encryption, right? This is standardized through the CSI, and the CSI is just a common mechanism for Kubernetes to say, look, I give you this instruction, which is to create one PVC, et cetera, et cetera. So there's no, let's say, enterprise-grade primitives in that space, right? So we are really sitting between two layers, between your, let's say, local. So we essentially combine and aggregate all the local drives to create a pool, sort of a pool of consumable storage. And on top of that, you just deploy your application. And what is important about Ondat, and we're going to see that it's completely Kubernetes, so using labels and this kind of primitives to configure the different capabilities such as replication, encryption, compression, caching, etc. Okay, so I think I've talked enough about what we do. So what are the challenges with stateful set on top of that? So if for that we have to compare them to normal, I would say stateless application. So this is the one on the left on the screen. So if you look at stateless application, they are deployed as Kubernetes deployment, which consists into a set of highly available pods. On top of that, you build your service, and the service essentially presenting a VIP, so virtual IP, so that you can access a single endpoint, and then it will be backed by all your different pods. Now, if those pods need to write to disk, there are different mechanisms to do that. If it needs to write temporary data, probably you're going to be using mtdr, which is sort of temporary storage into memory. It doesn't change. I mean, it's completely lost across reboot, when the pod is deleted or restarted somewhere else. So if you need to write to a persistent fashion, you have to create what we call a persistent volume claim. So the same way, let's say container consume pod resource, compute resources, or a deploy pods, a PVC will consume physical volume, or PV, physical volume, or persistent volume in that case. So those PV can be either created automatically if you use the proper CSI, or can be pre-provisioned by the admin. But typically, you use in a pod manifest or in a deployment manifest, you will use persistent volume claim to say, okay, I want to use that much storage, and I want to have from that particular storage class, or the system will make sure that the storage that is backing your PVC will have enough space. But the important point here is that when you have a deployment, and within that deployment you use a pod template, the PVC that is attached to it is common for all the pods. What it means is that if it's a read-write once type of PVC, so we have two types of way of consuming the PVC, either read-write once, so every pod write to its own PVC, or read-write many, typically like NFS share, these kind of things. So it's easy to think about that, right? So if the PVC is read-write once, you attach it to the deployment, then obviously the first pod that is going to be created will consume it, but the other ones, well, they won't be able to write to that PVC, right? Because, of course, it's read-write once, and it's already taken, right? So typically, if you need to write to a common space within a deployment, you need to use read-write many. In that case, this is NFS. So again, NFS, shared storage. But if we're talking about things like databases, MongoDB, or Kafka, running on NFS, you will have a big hit on the performances, right? So it's not the way to deploy stateful application. Don't use deployment. That's essentially long story short. You have to use stateful set. So stateful set, it's the way they are deployed. It's a bit different in the sense that when you create, so it's still managing pods. So stateful set has a controllers. You can set the number of pods you want to deploy, like your target number of pods within the stateful set manifest, let's say 3 or 4. The stateful set controller will always make sure that you have those 3 or 4 pods deployed in the system. But the key differences, they are actually 2 or 3, right? First, on the storage layer, you don't use a PVC object anymore. What you use is a volume claim template. So what that means is that now every time a pod will be deployed, it will have its own PVC. That's the first thing. So you can have individual read-write once PVC for every pod member within the stateful sets. So that's a good news. You can effectively run a database. Everyone will have, so every pod will have its own storage space. Also, on top of that, it needs to have its proper identity, right? We're not talking about cattle anymore. We're talking about pets. So we need to have like the persistent and stable network ID. And for that, we essentially create what we call a headless service, which basically allows you to use the Kubernetes DNS to reach every pod by its name, right? And when a pod is deleted, it will keep its, typically if you compare to a deployment, you delete a pod, another one will be spun up. It will have a different name at the end, right? It will be completely random. With stateful sets, if you delete a pod, let's say we'll see in the lab we have Mongo, let's say Mongo-0, that will be the first one. If you delete it, it will be recreated with the same name, which means that its network identity from a name will be persistent. It will change IP, but the DNS name will be exactly the same, which basically makes sure that you can run those databases. It will be the master will always be the master, slave will always be the slave. So those are the two main differences. And I guess we can go into the lab for now. So this is the address there. I don't know if someone can just paste it, or maybe I can, or you have it, or who can do that? It's in description, so you should have it. And I'll go with you, right? So we're going to be doing this together, right? So the way it's designed is first we're going to have a step to complete the Kubernetes cluster install, right? So a couple of lines there to make to build the Kubernetes cluster. Then we'll see some application for deployment, and then we'll have some fun with the stateful sets. So it's should be done approximately, I would say, in 40 minutes. We should be good. All right, so we can get started. Normally, everyone should be able to log to your nodes. So there are two different ways to access your nodes, either via WETI or directly using SSH. Right? So I think everyone has password login to connect to the different machine. So for the first task, you will have to connect to the master, right, and to every worker. So what I did personally, I opened 2 tabs for the master, and then we will have 3 workers. Once we have installed the cluster, we won't need the connection, the SSH connection to the worker anymore, right? So I just wait like 1 minute for everyone to connect, and then we'll get started. If there are any questions, please feel free to ask your question on the chat, and people will just relay to me, or Angelos will respond. Okay. So the first task really is to do the last part, which is bootstrapping the Kubernetes cluster. So what I'm going to do, I'm going to read this out loud, right? So the objective of this workshop is to explore Kubernetes stateful sets and their use cases. So traditionally, Kubernetes applications are developed to run as web application. They don't often need to write persistent data to disk or need a stable identity. In the event of a node failure in Kubernetes, the control plane, not the controller plane, spawn new pods to match the expected number of replicas. So this is achieved by leveraging Kubernetes in deployment and replicas, as we see it. The pods they create are stateless and replaceable. When a pod is created, it takes an arbitrary identity with an auto-generated unique name. On the other hand, stateful sets are Kubernetes first-class object, providing pod with a stable identity and ensuring they can write to individual persistent volume. This is what we've been talking about. And they have additional characteristics we're going to highlight in this workshop. Right? So first step is going to be, or step 0 in our case, run this command on the master. Right? So you can copy the first line, connect to the master. Be careful, so playground at master should be your master. Oh, I didn't copy the right. Okay. Copy. All right, let's do that. Password, that's that. Okay, it should be pretty easy. Just take a 30 seconds, something like that. Then we're gonna create a folder and copy the kubeconfig file so that we can access the cluster with kubectl. Right. Pretty basic. Okay, I copy paste that. So now, normally, what I recommend is also to create an alias so it's easier later. So alias k equal kubectl, right? And I recommend to do another one, which is g for kubectl get, right? Oops, sorry. So you can see here, master, I've got a single node not ready yet. But what we want to do now is apply a CNI for the network configuration. Otherwise, core DNS won't work. Okay, copy paste that. You can check -A. So you can see like the CNI flannel is going to be provisioned. Okay, meanwhile, you should have a line there at the end of your kubeadm init. So you will have to copy that part. I do it in two ways. I mean, you can copy the whole 2 lines, but I prefer to go 1 line at a time. And you want to prefix this with sudo, right? So sudo, oops, sorry, not the master. Now you have to go on every worker and repeat the same step. So you have to add sudo before. And now the second part, which is this bit here. Okay. Worker here. Okay. Okay, here we go. Now I'm going to copy there. I'm going to repeat it to the master. Sorry, to the worker 2. Password again. And worker 3. Right, so let's wait. It should be quite fast, I believe. So this one is okay. Worker 1 is okay. Worker 2 is okay as well. And worker 3 as well. So now you want to go in. So in case here you have extra instruction. In case you lose like the screen for, with the token, you can use the command there to recreate it and to recreate a new one. You can copy and paste. So now let's just check. So I've got 1 master, 3 worker. Everything is ready. So we're going to do a lot of copy paste for Kubernetes manifests. The next one is really to get no extra weird tabulation spaces, all of that. If you don't do that, you're going to be in trouble. So yeah. Also on the right now on Git, you can copy, right? So you can do this. All right. Okay. Here we go. So now by doing this, I shouldn't have any problem later on with all the tabulation and all these kind of things. So now we're going to have fun with some application patterns in Kubernetes, how we can pass data to the application, these kind of things. So hopefully it's going to be fun. But the best part is really on the stateful set. Okay, so first task, we're going to create a pod, then a deployment, etc., etc. So let's create a pod. Just set the level. If you already know how to do this, you may want to skip and go directly to deployment. But let's do that. So an easy way to create a pod is to use kubectl or kubectl run in dry run mode and redirect the result to a file. We can then alter the configuration as needed. So if you guys, any of you plan to do the Kubernetes certification, the CKA, this is typically what you want to do to go super fast. If you need to create pod or deployment, use always the dry run methodology. And then you can modify the resulting YAML. So I'm going to run. Now you can close all the worker if you want to. Okay. Now I've generated the kubectl run nginx. So I'm going to deploy a pod, nginx pod. I'm going to use port 80 on the container dry run, which means that it's not going to create it, and I want the output to be YAML, and I'm redirecting this to the nginx manifest. Right. So now vi. So you can see this is what has been deployed, right? By using this dry run mechanism, this is the file that is generated. So I can directly apply it to Kubernetes if I want, right? But what we want to do is add an extra label. So what I want you to do, guys, is to add one label. You can add it if you know how to do it. You can just add the label in with the imperative command, or you can just add it here. Or if you want, you can just copy the whole thing there, delete everything there if you want, and paste it. Right, same thing. Okay, so now I've got my pod that is ready, and I can just apply the manifest to send it to the API, and I can check that the pod is ready. Right. So container creating, running, good. Now I just want to double check the container has the right label. You can see owner equal Nick, which is me. So replace by your name. Don't put my name, please. So everything is good there. So it's pretty easy, right? What we just did is just create a pod. That's it. So now on top of that, a pod by itself deliver like an application, but it's not highly available. So I'm going to read this. Probably you should read it too. It's important. So pods can be combined in a highly available Kubernetes object that ensures the intended number of running replicas is always met. This is achieved via the replica set controller. It's responsible for reconciling the current states of the cluster with the configuration stored in the Kubernetes database. So in the event of a node failure, pods running on that node and part of a replica set will be restarted on another node available. Of course, only if it matches the conditions to run them. Like if it's under pressure, then it won't be restarted. So this is done via the replica set controller, which leverages pod templates. So remember, we are in deployment. Replica set pod templates to deploy individual pods when required. The template object in Kubernetes defines the metadata and spec to be used by the pod when created. It's merely a wrapper around the pod objects. An example is there, right? So basically you have the pod, definition, the pod manifest, and you just put templates on top of it, and that's it, right? But remember, if you place a PVC into that template, all pods will leverage the same PVC. If it's not NFS, so read write many, only the first pod will have access to it, which is pretty bad. Again, if you want to use deployment, so stateless with shared storage spaces, you need to use NFS, which is bad for performance. Okay, so you can start with one only replica, and then you can scale imperatively using kubectl scale, which we are going to do anyway. But the recommended way to increase is, of course, to manage via replica sets, like decoratively. So just change it or plan for it using the replica field inside the replica set manifest. So on top of that, so we have the replica sets that is managing pod, and we have deployment, which are managing replica set, which are managing pods, right? So it's in the order. We have deployment, replica sets, and pod. So replica set control the number of replicas. But what is deployment doing? So deployment is a way for Kubernetes to provide a smooth way to upgrade applications. So typically, it allows you to do a rollout of new version of your application in a smooth way by maintaining at any point in time the expected level of availability. Also enables easy rollback, keep track of previous versions, making it the perfect ally to deploy stateless application. So we're going to experience this a little bit. We're going to create a deployment, scale it, upgrade the image, and then revert. So first, the deployment. Again, we're going to use the dry run imperative way. So kubectl create deployment. This is the name of the deployment. We're going to specify the image, the port we want to expose, and we're going to say we don't want to deploy it effectively. It's just a dry run, and we redirect it to a file, right? So same thing again. There we go. I'm going to ask you here, again, you can just add manually the line that are marked, or you can just replace the whole file, copy-paste. So what I want you to add, guys, is number of replicas there. That should be 2. It will be 1 with the by default. And then here, again, in the labels, add owner and your name, not my name. So let's do VI of that to edit it. Okay, so I'm going to do, because I'm lazy, I'm going to delete everything and just paste the whole thing. Oops. There you go. So now, if I go to the next step, which is just, again, send it to Kubernetes API. Okay, it's created. So just check that it's working. So you can see I've asked for 3, right? So 2, sorry. Is it 2 or 3? Yeah, 2. I've asked for 2 replicas. So therefore, I have 2 pods. So you can see what I've talked about earlier was it's like a random name. We're going to see with the stateful sets, it will be an ordinal number that is increasing, starting with 0. So it's really pretty much predictive. Okay, so now I just want to double check that the label, like with the owner, has been applied. The owner label is important because then later on we're going to play with it a little bit. So we have our first pod, right? We created before, and now we have our deployment there. So it's perfect. Then I can also do a kubectl get deploy to see the deployment. Of course, you will see the number of container ready, available. So far, so good. So now we want to scale it the imperative way, right? So this is this command there. kubectl scale deploy, the name of the deployment, and you just specify the number of replica that is desired, right? So, and suddenly, magically, we should see 2 more, right? Already running, which is good. So now I have got, the goal is to have those 4 pods. But they effectively deliver the same service. They do the same thing. They can be, they can be accessed individually, but anything you define into the deployment, the template for the pods, will be common to all those pods, including the storage again. Okay. So now what we're going to do, remember I said, okay, we have the replica set, which control the number of replicas. The deployment is adding another layer of features on top, which is about roll out new application, revert, keep track of all that. So what we're going to do, we're going to change the image, like it's going to be, so at the same time, yeah, that was the replica 4 from before. I want to change the image, which is this one there. But again, because I'm lazy, I'm just going to copy everything, delete everything from the file, and paste it. But you can see it's another image. It's not Nginx anymore. All right. So now the way to do a rollout of the new application is just to apply, right? Because Kubernetes is smart enough to do a comparison between what is currently working, because between what is currently running and the new configuration, which is basically now we can detect the image is going to be different, right? So it's going to do this, and now if I do kubectl rollout status, it's going to tell me what is happening, right? So that's the job of the deployment controller, is to make sure that at any point in time, the right number of pods are still available. So there is this whole like update strategy where you define a maximum kind of extra pod that can join before the other ones are destroyed. And in the same way, you can fix a minimum number of pods that should always be available, including during upgrades. So all of that you can tweak if you want, but by default, it just works, right? But maybe a bit different depending on your environment. So here it's just telling me, okay, that many pods have been updated, replica then are deleted. Now it's just telling me, okay, now it's successful. So you can see here I still have like one old pod terminating, but now the deployment is still the same, but I've changed the image, right? So now I've got new pods with a new image running, and all of them are providing the same service. So far we just define deployment pods, but it's not accessible from a service. We don't have any VIP associated with this, which means that there's no way to really access the service in a highly available fashion. We need like a single IP to be connected to this. So what we're gonna do, we're gonna stay within the cluster. So this is why we're gonna be using cluster IP. Later on, I will show you how to expose the service outside of the cluster. But for now, we're gonna create a service, expose the service out of that particular deployment. So again, you can create a service manually if you want and build the manifest. But again, if you plan to take the CKA exam or CKAD, any of the Kubernetes certification, I really advise you to get familiar with those imperative commands, because it will go a lot faster and the lab is difficult. So this is creating a service essentially, because now you can see I've got my service. It's there, right? So it's a lot faster than just creating the whole manifest for that. So it's there and listening on port 8000. Although the pod itself, so yeah, maybe I should explain this. The port 8000, this is when you want to access the VIP. This is going to be on port 8000, but the port where the service is running on the container itself, so the process responsible for the HTTP server is effectively running on port 80 on the server, right? But port 8000 this is the one for the service, right? So we want to access this global VIP. This will be on port 8000. So for that, now what we're going to do, because this is a cluster IP, it means it's only accessible within the cluster boundaries. So we want to test this application, the image. So we want to do a curl on this port 80, right? So for that, I'm just going to create a new pod. So this pod is basically the curl image. Once the container is deployed, I can access the curl command, right? Which is exactly what I'm doing after kubectl exec-it client -- and then the command I want to type to get access to the service. So you can also notice there, Kubernetes has a predictive way, and this is why it's important to get service. It's not only a VIP, it's also accessible by its fully qualified domain name. And the DNS that is installed in Kubernetes is responsible for that. So it's always the same thing. Name of the service, name of the namespace, .svc.cluster.local, and then the port that you have created. So by doing this, what it's going to do is going to access one of the pod in a random fashion, like a round robin type of access. Oops, it's not this. So copy that part. Okay, so the pod is basically delivering a service that is displaying with ASCII, hello from Kubernetes. This is quite static. I didn't influence this. So now we're going to see how to influence that. But before that, let's try the rollout history, and then we're going to revert back to the old image. So if I do kubectl rollout history, it's going to tell me, okay, you can also, so the change cause, this is something you have to enter manually in the manifest, right? If you want to, or when you deploy a new manifest, a new version, changing, the container image, all of that, it's in YAML, you have explicitly to define the cause. Because I didn't do it, it will always be none there. But what is useful is that I have a second revision, right? So now, if I want to revert back, I mean, if you have many different revisions, you can choose the one you want to revert back because, but because I just want to do the previous one, I can just do undo deploy, it will revert to the previous one. Again, this is thanks to the deployment, right? Not the replica set. It's because we have a deployment on top of the replica set. So now, if I check what it's doing, it's basically reverting all the pods. So same methodology, making sure it's still highly available, terminating the pod first, and then provisioning new ones. So it's already done it. And just to confirm that it's the old image, let's test it. And you can see it's not the hello from Kubernetes, it's the basic, Nginx sort of landing page. Okay. So hopefully you're doing well. Again, if you have any question, any issues, don't hesitate to write in the chat. So now let's go to the next step, which is more around, okay, I've built my application. It's pretty much static. How can I give it more, dynamic? How can I pass dynamically, variables so that I can change the behavior? Which in our case, we try to display something else than just hello Kubernetes in ASCII. So again, we're going to be using the same as before, our Nginx deploy. Now what I'm going to ask you is to add an environment variable there. And so what we're going to do, so remember the label owner I've asked you to create. We're going to be using the content, the value of that label, pass it to the application so that it's going to display your name, right? So what I wanted to show there, it's you can reference what we call the downward API, meaning that the application can be aware of the platform. So what I mean by that is we are passing an element that is defined in the manifest, that is running in the cluster. In the API, we have enter, name, the owner is Nick, right? So this is something the application is not aware of. Now we can pass that value because we're running Kubernetes. So, and this is how you can reference the downward API, right? So metadata.labels owner. So it's going to tell the application when the container is spun up by Kubernetes, use that particular field that is not living in the application, right? It's living in the Kubernetes environment. Get that particular metadata.label named owner and pass the value as an environment variable, right? So essentially Kubernetes allows you, and this is one of the very, this is why Kubernetes is super powerful, is that it can make the application aware of where it's running. And you can get a lot of context and metadata from the platform, which is really, really useful. But yeah, the example is rather simple, rather trivial, but it just gives you a quick view of what is available. So again, because I'm quite lazy, I'm just going to copy everything. Just one. Okay. Okay, again, if you want to, like a quick tip, if you want to take the CKA exam, if you want to replace pods or any manifests, rather than deleting and applying, you can use this command, which is going to scratch everything. So kubectl replace --force-f and your manifest. It's a very efficient way to replace what you already have. Because if you try to replace, sometimes there are fields you cannot replace by default. So if you just want to apply, the API will insult you saying, yeah, no, it's already running and I cannot modify that particular field. In that case, you do replace, force, and job done. Easy peasy. Okay, so now replace the current deployment. Okay. Oh, I didn't save, I think. Here you go. I'm going to copy this. I cannot talk and think at the same time. It's very difficult. Okay, so I do a replace again. There you go. Now, because it's not like a rollout or running updates, it's going to terminate all my container at the same time. So it doesn't respect any sort of, availability for containers. It's just ripping everything off. So don't do that in prod. But for CKA exam, it's okay. So now, what you can expect is your name should come first. It should be more dynamic, right? Okay, so Nick was here. That's me. So you should have your name was here. Okay, so that's one way to pass data to the application. Now we're going to see another pattern, which is the init container. So the concept of the init container is, so a pod, probably you should know that, right? A pod is the smallest unit of what you can configure in Kubernetes. But at the same time, in one pod, you can place more than one container. And one of those containers can be an init container. The role and the difference between an init container and a container, normal container, is that the init container will be run before all the other container, and it's limited in time. So once it has finished its job, it's done, right? It's not going to do anything. So the idea here, we're going to be using this init container to basically copy a message into a shared storage space, which is, again, it's mtdir. We're going to use mtdir. Mtdir, remember, this is kind of a temporary memory, storage space. But and the lifetime is the lifetime of the pod. But remember, those two containers are running in the same pod, which means that the init container can write information to a volume, an mtdir volume, and then once the normal container is started, this container can then read that shared storage, that volume, and do something with it. The only thing you have to make sure is that the volume you mount in both container. So here, the mount path, mnt message, in the init container and the normal container are the same, right? So they access the same shared volume, right? So I'm going to write the information instead of the environment. I'm just going to tell, okay, this is my name, use this. So just using like shell command, echo the host name, right? So I'm using the pod name now. I would put this into a text file, and then the main container, right, the Flask ASCII container, will read that message and display and serve on port 80. So again, you can copy the whole thing. Let's deploy, right? Be careful where you copy, right? Paste that, and again, we're going to replace. Okay, you see again, terminating. And now you will see two containers. We have one more information, which is pod initializing. So we have one more container. You see, it's still ready. It's still one container because the init container dies. Its job is just like to prepare the container. It's like an init function. Really, nothing more. So here you can read, mtdr gives every individual pod a temporary local in-memory storage. So remember when I said if this persistent volume is shared between all the pods, mtdr will be specific for every single pod, right? But again, it's only in-memory temporary storage. So the message display should now be different for every pod, as it's based on the individual pod host name. So let's run the same command again. And because I'm using the service for that, I should have a different answer every time. You see? Like it's different number, like ZGDL, this one, ZKM9P on the other one. And every time I'm going to run that, I will have a different answer. It's because every pod has access to its own mtdr, right? So this is a way. Remember I said NFS is the only way for persistent volume in a deployment, but their mtdr, this is what you have to use if you want to write data individually for every pod. But at the same time, the downside of that is that it's going to die when the pod is stopped. So it cannot, again, it cannot be used for a database, for example. That doesn't work. Okay, so that was it for the deployment. Now we're going to play with stateful sets. We're going to experience sort of the same thing. What are the key differences? But before that, just the conclusion there. So in summary, while mtdr provides individual storage for every pod in a deployment, its life cycle is tied to the pod, right? So if the pod stops, volume, the mtdr volume is deleted. When persistent data is required, you need basically to use persistent volume claim. But how we define configuration in the deployment is by using a template. And this template will just give you a single PVC, right? So in that particular PVC, then we'll typically write once. It will be a single volume, which means only the first pod that get access to that volume will be able to write in that volume. So for this, to solve that, you have persistent volumes. So persistent volumes, stateful sets. Stateful set will provide something that is called volume claim template, right? So that every single pod within the stateful set will have its own persistent volume. Okay, so the rest, I give you here a couple of other properties of stateful set that you can read at home. We're not going to play with it, but it's very interesting to understand, a bit deeper what are the different properties. But of course, before I want to show you what Ondat provides in terms of feature set for the volumes, because this is our play, right? This is where connecting the dots with Ondat is that we're going to be providing a enterprise-grade feature for this distributed persistent volume layer to make sure that you have replication, encryption, compression, like we do fast failover, all those kind of enterprise-grade features that are missing in Kubernetes, right? Because by default, in Kubernetes, if the volume is local, right, is local to your node. If the node dies, the system is going to try to restart the pod on another node, but it was local, right? So the volume is not accessible. So the job of Ondat will be two things. First, to replicate the volume when you need it, but also to make sure that even if you restart the pod on another node than the node where the volume is located, we provide an internal network protocol so that it can still access the volume that is remote to another node. All of that completely seamlessly, right? So from a Kubernetes perspective, it's completely transparent. And this is really what is great about that. Okay, so now, again, to install Ondat, well, it's single command, so it should be pretty smooth. So go to your master. You can watch what is happening on a second tab. This is why I had Of course, I didn't create the alias. So Ondat is going to install a couple of things. The main, I would say the most important one is not there yet, is our Daemon Set. So the Daemon Set is what will bring the whole function locally to every node, and will give you the ability to leverage the local storage space for every node and create an aggregate sum of storage you can use. So we have multiple components. As you can see, we have an etcd we use for our own database. This is the self-evaluation version I'm using. So we create an internal etcd database. Typically, we recommend to, if you want to go to production, to have an external etcd. We have, of course, our cluster operator that is going to provision on that cluster. And we have our API manager that's going to talk to the Kubernetes API and maintain relation with that, and the CSI helper, which help with the CSI integration. So it's in error here, but it's going to try to give it a bit some time for etcd to, it should reconcile at some point. Yeah. Okay, let's check. Still waiting to be ready. Take some time. We have a 3 node etcd cluster there. So you can see init, same principle of what we just saw, init container. Okay, so now it's ready. Let's go back to the instruction. So the first thing we do, if we kubectl get storage class, we install a storage class that is named fast. So now every time you in your volume claim template within the stateful set, the only thing you have to do is specify that storage class. As soon as you do that, Ondat will take care of the underlying storage and volumes. As easy as this, right? So we're going to be using a MongoDB stateful set for that. So just copy again this portion. So remember, we need a service, headless service, when it's a stateful set, so that every pod can have its distinct FQDN. If you don't create a headless service, the individual pods in the stateful set won't be accessible by their name. So basically, you're a bit screwed. So that's one thing. You define the port. You want to expose MongoDB standard replicas as before. What I want to show you, guys, it's here. Volume claim template. This is the important key bit. You give it a name. You just give it the access mode, read-write once, because we want every pod to access its own persistent volume claim, persistent volume. Specify the size, and most importantly, just specify the storage class name. Single parameter, super easy, but just don't forget it, right? If you do that, Ondat will take care of the rest. So let's copy that. I'm going to do this. Okay. Then we can simply deploy that. We're going to deploy our first stateful set. So service is created, stateful set is created. So what you should see if you do kubectl get pod. Now, see the difference there between a stateful set and deployment. Stateful set will have, so two things is going to happen. One, every pod will have a stable name. So if I delete MongoDB-0, if it's respawn on another node or the same node, will have the same name. If I delete one pod there, it will have another name. And second thing, maybe you don't see it here, but it's going to proceed with the next pod only after the previous pod with the lower ordinal number has been completely created and is running. So basically what that means, it will do MongoDB-2 only after MongoDB-1 is running. if for deployment, it doesn't care. It's going to just deploy everything at the same time. So this is why it's going to take a bit more time. You can change the settings if you want. Like if you don't need this sequential startup, you can change it. Oops, sorry, I've reapplied the same thing. Okay, so now we have our 3 node for the DB. So just double check that all the elements are there. So what is interesting is to see we have now our stateful set, 3 out of 3. We have our service that is set up, the MongoDB, still using a cluster IP at this stage. Headless service. We have our 3 different PVC, persistent volume claim. They are bound. So when you are using Ondat, we are, just by specifying the storage class, we will create the PVC as well as the PV. So, you know, PV is something normally the storage guy, the platform admin or the platform engineer looking after Kubernetes needs to pre-provision. But depending on the solution, you can provide like automatic creation of the PV if you just use the right CSI, the right storage class, the right provisioner. So in our case, we just create everything for you. It's automatic. Just specify the Ondat storage class. And yeah, everything is just automatic. So now we also have a container that allows you to run our CLI. So you can install the StorageOS command if you want to, but we also embed into the deploy. If you do like a here, display all the pod, you have like a CLI container, so you can use that one to run the Ondat CLI or StorageOS, which is the engine behind Ondat, right? So we're just going to do a get volume in the default namespace to see the volume from a Ondat cluster perspective, right? The cluster that we have built, you can see at the moment we have 0 replicas. You can see that the location of the volume is worker 1. So this is effectively where the volume is created. Attached on essentially means where the pod consuming that volume is running. So we will always try to collocate them. So from, if the pod is running on worker 1, we try to get the volume running on worker 1 too. But sometimes it doesn't happen, and we're going to test that. In that case, the volume can run on another node and we'll provide the network protocol to reach it. Okay, now let's initiate the database. So we're going to do it manually, which can be, you should not do that because whatever I'm going to do like in an imperative way is not, let's say, memorized or saved by the pods. And this is why you should use a database operator. And that's the second part that is very interesting about stateful set and database. Just don't run stateful set like that. You have to use an operator because the operator will facilitate the, all the operation, the maintenance on all your databases. Okay, so let's connect to, we're going to be working with MongoDB 0, the first one. Even though we're going to create a cluster, really we're just going to, we're just going to interact with MongoDB 0. So those are basic MongoDB command just to make the cluster happen. Okay, so I'm just saying like Mongo 0 is going to be the first one. I'm going to add Mongo 1 and Mongo 2. Okay, so now if I do rs status, I effectively have deployed my MongoDB cluster, and as you can see, every one of them has a dedicated name, and actually if you delete one of those, it will be restarted, but it's going to break because although the data will be there, we are not using any operator or saving any configuration, right? So you have to take care of that part. So now we are going to be deploying an app to effectively use that database. So, and I think this app is quite fun. If you are a Marvel fan, it's going to be fun. So we're going to populate the database using a Kubernetes job. So this is another construct that is important in Kubernetes. If you need to do like one thing off, or you can do cron job as well. But if you need to have like a particular workflow that needs to run once, you can use a Kubernetes job. So the job, you can, for example, you can say, I want it to run 4 times maximum. So if it, it's going to fail up to 4 times, and then it's going to stop. But basically, you can say, I need it to succeed once, and maximum try only 4 times. So this is this kind of aspect you want to use with Kubernetes job. So what I'm going to do there is effectively I'm going to populate the database of MongoDB using the job. And in the job, what I'm going to do is querying. I mean, you can take a look at the images on GitHub, but on Docker Hub. What it's going to do is going to call the Marvel APIs, just query and store the result into the database. And then we're going to display, the information out of that. So every time we're going to be using the application, it's not directly querying the API, it's by using what you have in cache in the database. Okay, so we're going to create a job. So for exits here. And now, I didn't miss anything. No. Oh, yeah, I've just created the file first, right? So this is what is there. Again, you can use the dry run. And you have to specifically add this part. Again, you can copy paste the whole thing, which is just like the basic, variable I need for the application to run. So it's just, setting some input for the app running in the job. There you go. Now, again, as usual in Kubernetes, just apply. Okay. So you can do 2 things. You can do kubectl get job or get pod. It's still running. So you can see it's not completed yet, but the pod is running. Completed. So now the pod is not running anymore, and the task should be completion. If it fails, you're going to see like other pods, keep popping up, like 4 times maximum. If we say only do 4 times, and then eventually, if it succeeds, it's going to be just completion 1 out of 1. So now, we should check if the database is effectively populated. So for that, we're going to be using another pod to query the database. So this is another image. It's going to provide you with a Mongo shell, and we're just going to run Mongo command to verify that the DB has been populated. It's going to take some time. Here we go. So you can use Marvel, right? Which is the name of the database. Okay, show collections. Characters, which is, and then I want to count how many entries. So now 128. So the job worked. If you want to see what is there in terms of the information, you can just do that. It's going to tell you, you can type it at the end. So this is all the information I'm gathering from the Marvel APIs. Like the name, the thumbnail, and different information. So it's working. You can type exit when done. Now we're going to create the front-end application that is going to query this database to display the information in a nice way. Right? So again, you're going to be using another image. This time, this is going to be a deployment. Right? This is the stateless application. This is the stateless part. So again, we use the dry run. And then we're going to specify a couple of other parameters. So again, here is just to access the first database. In a production environment, you should access all the member of the cluster when you do Mongo query, but it's just testing there. It doesn't really matter. Okay. apply again. So we have creating our front end. We can do get pod. You can see that here is going to be created. Just verify using the command. Everything is running. Everything is fine. So again, like before, we're going to expose it. But this time, we're going to be using node port because the Kubernetes nodes are directly accessible from the internet. So we're going to be using directly, the node IP address or name. So again, it's exposed. Get service here. So node port means that I can access any node of the cluster on that port, and the application will be available. So let's check this. I think this is it. Yes, right. So it should be working. Like worker one with the right port. It's not the right port. Here you go. Maybe a little bit bigger. So the application is there, and you can just refresh it if you want. It will, regenerate kind of random character with all the information, all the comics where it appeared, and you can reload individually as well. Oops, no, this one's not working. That should be working. Obviously, this is the live effect. Yeah, but at least the full page reload is working, and this one too. It's only that one. No, it's working now. I mean, okay. It's weird. Okay, so we've done it. That's cool. So now we're going to start breaking things. Yeah, just 5-10 minutes, and then we should be done. So now you can be proud of yourself because you've deployed a database. You made a cluster out of it. You've deployed a stateful set out of for that database. You've deployed a stateless application, essentially doing microservices. One of the microservices is a database. The other one is a Flask application. So you're effectively a developer now. Maybe you can put this on your CV now. Okay, so let's break stuff. So remember, we still have 0 replicas. So if I break stuff now, I'll be in a bad position. I won't have any job tomorrow. So still 0 out of 0. Now to show you how easy that is to configure replicas with Ondat, when I say it's Kubernetes, the only thing I need to do is to add a label setting the number of replicas. And that's it, on the PVC, right? That's it. I just have to do this. Okay, now it's labeled. And if you do the same command again, you can see number of replicas 2 out of 2. So now I've got, for all those PVC, I've got 2 replicas. They are essentially secured. Same thing if I want to do encryption. I just have to add a label with encryption. That's basically it. So now what we are going to do, we're going to make sure the pod, so yeah, maybe I should explain this. So you can see, like, if I do a get PVC, you can see MongoDB 0 is attached to the volume PVC A3 something, right? So if I go here, A3 something, this is worker 3. So the volume is currently located on, so PVC is currently located on worker 3, and doing this presentation layer, this overlay presentation layer, to worker 3 as well, right? Because this is where essentially means the pod is currently working, running on worker 3. So what I'm going to do, I will make sure to evict the pod on another worker to show you that it continues to access worker 3 data. But before that, we can access again the database. So that's MongoDB-0 bash, right? And I'm going to do ls cd data cddb. So this is what is important there, right? We have all our data that is there. So what I want to make sure is that this part is not empty after. So how can we do to isolate the pod on another node? Well, if I delete it, it's going to be restarted on the same node. What I need to do is to cordon the node. If I cordon the node, it means that pod cannot be rescheduled on it, right? So when I delete the pod, the system will try to restart it on the same node, but I won't be able to do it. So it will restart it on another node, effectively, having the pod on one node and the volume attached to, and the volume residing on another one. So let's do this. So cordon, we say cordon which one? Worker, so again, double check. We want MongoDB 0. This is A3. A3 here is worker 3. So we want to cordon worker 3, okay? So now I know this node cannot run any container. Double check this. Node scheduling disabled. All right. So let's get wild and delete our stateful set. So again, when you see, it's going to try to create MongoDB 0 again. Same identity, stable identity. The PVC has not been destroyed, so it's still the same PVC that is attached to it. All right, so it's still attached to it. It's this one there. So, but now, it doesn't seem like that, but look at, if I do kubectl get pod -o wide, you see the MongoDB is now on worker 1. So now we have the volume on worker, what was, I can't remember now. We say worker 3, I believe. Yeah, worker 3. So we'll just go back to the command. So here you can see it. That is this particular volume. It's currently located on worker 3. That's where the volume didn't move. It's still on worker 3. But the pod is running on worker 1. Right? So Ondat, and this is thanks to Ondat that the pod can be restarted, because now from worker 1, the worker 1, the pod still think it accesses the volume locally attached, because Ondat creates this sort of overlay that is presenting the volume locally. But in reality, it's using a network protocol that we use to present that data to the pod, right? So now let's check the data is still there, because yeah, otherwise that wouldn't make a lot of sense, right? So connect to the database again. Go to /data and db. I'm scared now. Will it work? Yes, it's there. No surprise. Okay. We're going to uncordon. And the last thing I want to show you, which is really like the hard, let's say, being wild in terms of what we're going to do. We're going to shut down the node, reboot the node where the primary volume is located. So essentially, what we want to trigger is now a new replica should be promoted as the node where the primary replica is rebooted. So two things are going to happen. A new replica is going to be promoted. The pod should still access that particular, the new replica. And in parallel, because we have now one less replica, the system will create, will trigger the creation of a new replica, because we always want 2 of them, right? So we need to create a new one to reach 2. So those 2 things happen like almost instantly, and we'll see like the data will still be there. So now I need first to uncordon the node. Exit there. Uncordon worker 3. There you go. And check the nodes. Now all my nodes are schedulable. And now I shouldn't make any mistakes. So now we want to start the node where the volume is located, not where it's attached. which is in our case, remember that's worker 3, right? Worker 3. Just to be sure, I'm just rerunning the command, right? So the volume is located on worker 3, attached on worker 1. So we want to restart worker 3. So worker 3, which is, must be that guy connected there. So what's going to happen? Yeah, we're going to see stuff happening. Let's just do it. So shut down. Oops. I don't like to do this kind of stuff. I'm always kind of... OK, done, finished. No more volumes. So what is happening right now? See? Almost instantaneously. The new replica has been promoted. Replica 1 out of 2. But we are resyncing in the background. So now, if I do that, oh, I broke everything. Or maybe the pod was, the CLI pod was on the node. Yeah, OK. Yeah, still replica 1 out of 2. It's going to rebuild eventually. OK, in the meantime, let's check that. So that's Mongo, right? So get pod. So the pod is still running, right? It's still there. We just rebooted the node where the storage was sitting. So if I do again, let's connect to the Mongo 0 / data db crossfinger. There again, right? So we didn't lose, even though we rebooted the host, we still have the data that is there. And now just the last part is just to show that we've got, yeah, now so what Ondat did is on top of promoting the first replica, because now there was only 1 available, we want 2, it has created a new replica on one of the remaining nodes, right? And this is why I wanted 3 nodes and 2 replicas. Okay, so what is this? I'm sorry. Oh, it's my radio. I'm sorry. I like to listen to chill tracks when I'm working, and sometimes it's just like popping up, which means that it's time to stop working, probably. OK, that was our last task anyway, I believe. Yeah, perfect timing. So I believe that was the last one, yeah, showing that essentially we have now 2 replica. So that's it for today. Hopefully you had fun. At least I had fun. Preparing it as well. So it's available. I mean, it's just sitting there. So you can, if you want to, just do it again or share it with other people, try it. The only thing you need is a Kubernetes cluster. I mean, it works on EKS, AKS, and this is why Ondat is so good as well, right? We are kind of Kubernetes. We don't care about the cluster. So pick the distribution you want, and you can just practice the lab. If you have any questions on the lab, any comments, or if you want, I mean, feel free to do pull request if you notice like typos and stuff like that, or if you want to see anything else. My contact is there, so you can do pull request or reach me through a, any social network. I don't know if you guys want to close it or. Sure.
Say you're using ANSI database. You're using that for metadata.
Correct. Yeah, for metadata.
Does that need to be backed up? And can you back up also the data that is on the storage?
I would say I think you also need to defragment etcd, right? And obviously, do we need to back it up?
You can back it up.
You can, but
etcd data changes all the time.
so
Basically the state of the cluster. So you can back it up, and we recommend to back it up, but doesn't necessarily mean that you can always recover those backups. It's recommended to make sure that you have a highly available etcd.
Oh, sorry.
talk.
Sorry, I was saying again. It is recommended that you back up etcd, but again, because etcd represents the state of the cluster, it changes all the time. So if you have a failover or anything, it means that
Yeah,
etcd
the
will change,
backup is
and you
not that-
can't really back up
Yeah.
from a different if restore from a backup if the state of the cluster has changed. That's why instead we recommend to set up your etcd cluster in a very high available environment. For production, for example, we recommend to be outside of your main cluster on 3 different nodes. So we make sure that this doesn't happen. So similar to how Kubernetes
Yeah.
uses etcd.
I mean, it's always changing, you know, metadata. So yeah, backup is, it wouldn't really help because in the end, if you restore that, the storage will have probably changed in between, so you cannot do anything with it. I don't know if there's any question online or no. People just probably went for dinner or.
I think you already answered the one we had.
I think we're good.
5 minutes
We can close.
All right. Check one, check one. All right, thank you everyone that came along. Really good seeing you guys. Yeah, we're planning to do one more before the end of the year. Is that right, Patrick? Yep, perfect. Yep. So please keep your eyes open on social media. We're going to get something out probably over the next couple of weeks, if not a little bit sooner. Yeah, thank you for all the guys that attended. Thank you for the tech support team over there. Really good stuff. Yeah, and thank you for coming.
My
Cheers.
pleasure, or our pleasure, should I
Yeah,
say?
thank you very much, guys. Cheers. Bye bye.